Alternative series test. An alternative series is any series like this: A0 minus A1 plus A2 minus A3 plus A4, etc., without stop. And each AN is positive number or zero. For example, 2 minus 7 plus 5 minus 11 plus something minus something, etc. So this is called alternative series. So I can write this series as sigma AN times 1 times minus 1 power n from n equals 0 to infinity. If I put n 0, I will have this term, a0, or n equals 0. If I put n1, I will have minus a1, etc. So we have a theorem here said that if an always positive and decreasing and approaches 0 when n goes to infinity, then this series converges. For example, if I take an 1 over n, so the first condition is correct, the second condition is correct, the third condition is correct. So this gives me that sigma minus 1 power n over n converges. It's less than infinity. Okay, if I write here instead of n power 2, also the first condition correct, second condition correct, third condition correct for an, so this series converges. Okay, let's see some examples. So to study this series, let's suppose that here an is minus 1 power n. Wait a minute, an is 1 1 over n power 2 plus 1. So this series sigma minus 1 power n times an. So I have first condition, it's correct, positive. Now, the second condition, that an approaches 0 when n goes to infinity, also correct. The third condition will be also correct. Why? Why an plus 1 less than or equal an decreasing? Because if I take the function fx equal 1 over x power 2 plus 1, so this is decreasing. And why this is decreasing? Because if I take f derivative x, so it's minus 2x over x2 plus 1 power 2. And always here n bigger than 1. So here I suppose that I'm studying the function on the interval 1 infinity. So this is always negative on the interval 1 infinity, because x greater than 1 and n from 1 to infinity. So remember why this derivative is calculated like this. If you cannot understand, we have a rule here. If you remember, what is the derivative of 1 over jx? Let's remember this rule. It's minus j derivative x over j power 2x. Okay. So using, because all the conditions are satisfied, now using alternative series test, using alternative series test, sigma minus 1 power n over n power 2 plus 1 converges from 1 to infinity. Let's take the second example. In this example, if I suppose this series minus 1 power n times an So I suppose an is 1 over 2n plus 1. So this is positive. And also an goes to 0 when n goes to infinity. And an is decreasing also because the function fx equal 1 over 2x plus 1 is decreasing on the interval. If the beginning here 1, so it's from 1 to infinity. So because here from 1. So why this is decreasing? Because if derivative x, it's minus 2 over 2x plus 1 power 2. So this is always negative. So all the conditions of the test, this test, alternative series test are satisfied. So sigma minus 1 power n times an converges. So sigma minus 1 power n over 2n plus 1 from 1 to infinity converges by alternative series test. Alternative series test. Now let's see this general example. Whatever b, so b any number different from 0. If b0, I will have minus 1 power n diverges. But if b different from 0, so this is always converges. You will see that. Why? By alternative series test. Alternative series test. Let's see if I suppose this is minus 1 power n times an from 1 to infinity. So what is an? An is 1 over n power b. So this approaches 0 when n goes to infinity. So I suppose here b any positive number. So b must be positive in this exercise. So r plus. So these terms are, if b minus 1, so it will be, this will be n power 1 over n power minus 1, it's n. It will not be, the limit will not be 0. Okay, so I will suppose here b greater than 0. Now the first condition is satisfied. The second condition, an less or equal an minus 1, so decreasing. This is correct. Why? Because if I take the function fx equal 1 over x power b, so what is f derivative x? It's minus b x power b minus 1 over x power 2b. Okay, so this because x positive, x greater than 1 also, not only from, because n from 1. So my variable will begin from 1. So x greater than 1, so this term will be negative. Because also and b positive, so this term will be negative. So my function is decreasing. So all the conditions of the alternative series test are satisfied. So this series converges. Let's take this series. So let's write the general term of this series. So remark here, root 2, root 3, root 4, and plus minus, plus minus. So here you have 1 root n down and minus 1 power what? If I give n 1, it will be here minus, but the beginning is plus. So let's write here n minus 1, for example, from n equal 1 to infinity. So let's take, so this series is equal sigma minus 1 power n minus 1 times an from 1 to infinity. So let's take an here is 1 over root n. So this is positive, always positive, and approaches 0 when n goes to infinity. And also an is decreasing and is decreasing. Because if you take fx equal 1 over root x, so f derivative x will be less than 0. Or you can say that another method to justify why it's decreasing, because root n plus 1 greater than root n, so 1 over root n plus 1 less than 1 over root n. So this is an, and this is an plus 1. So now all the conditions of the theorem are satisfied. So by alternative series theorem, alternative series theorem, so my sigma minus 1 power n minus 1 over root n from 1 to infinity converges. The last example here, cosine n pi, remember that cosine n pi the same as minus 1 power n. We explained this in some previous lessons. So this is equal to sigma minus 1 power n over ln n from 2 to infinity. So let's take, this is sigma minus 1 power n times an from 2 to infinity. So let's take the term an. So an is 1 over ln n. So this is greater than 0 when n bigger than 2. When n, or ln x, when x between 0, between 0 and 1 will be negative. If x bigger than 1, it's positive. So this term is positive. And this is approaches 0 when n goes to infinity, because ln n approaches infinity when n goes to infinity. Now, the last thing that an is decreasing. Because the function ln is increasing. Because ln n is increasing. So in general, remember that if we have, if the function jx is increasing, so 1 over jx and positive. So 1 over jx is decreasing. Why? I suppose this is fx. So fx equal 1 over jx always decreasing. Because what is f derivative x? It's minus j derivative over j power 2. But j derivative is positive because of increasing, j derivative is positive. So this term will be negative. So here we can say that ln n is increasing function. So 1 over ln n is decreasing function. So all the conditions are satisfied. So my series here, sigma minus 1 power n over ln n from 2 to infinity converges by alternative series theorem. Alternative series theorem.